Welcome back, guys. So today we are going to discuss the decimal to binary conversion, and in this regard we are going to solve question number 11 of section 2.3, in which we have to convert each decimal number mentioned here to binary by using the sum of weight method. Okay, so what is basically the sum of weight method? So let me first use the part A of my questions here, so that is in decimal. Okay, so basically I know that in all the weights, when I convert the decimal number into the binary one, so I have different weights. So those weights basically starts from 0, and those are basically the powers of 2, so that start from 0, then 1, 2, 3, 4, 5, 6, 7. Okay, so these are different weights and their values. If I calculate their values, so let me calculate their values. So the value of 2 of 0 is, let me have it 1, this is 2, this is 4, this is 8, 16, 32, 64, and 128. Similarly, if I have this 2 raised to power 8, so it will be how much? 2 raised to power 8 is, sorry, I have used the blue color here, so that is now 256. Okay, so these are different weights. In order to convert my decimal number into the binary one, I have to use these weights in addition. Okay, so using in decimal to binary conversion by using the sum of weight method, what we have to do, if we have a decimal number, let me call 12, so I have to search for the highest possible number here, which basically matches my decimal number here. Okay, so what is that highest possible number out of these three? So this is basically this 8. So let me select this 8 and write 1 with it. Okay, so with 8, what are the other lowest possible numbers which can be, when added to 8, will give me this 12? So that is clearly this 4. So when I will write 1 with it, the others 2 will become 0. So therefore this is the binary number which is equivalent to my number here, because when these will be added together, okay, so what will happen? So when this 8 multiplied by 1, when I will have 8 multiplied by 1, 4 multiplied by 1, 2 multiplied by 0, and 1 multiplied by 0, and when I will add them together, what I will get? I will get here 12 in the decimal number system. So therefore this 110 is the equivalent, 1100 is the equivalent binary number for this 1210. Okay, so that is the procedure for which I have to use this table. Okay, so this was my part A. Similarly, in order to solve part B of my question, what is that? That is 15. Okay, so that is now 15 in decimal. So what is the rule of thumb? What you have to do, you have to search for the highest possible number which matches my number here. Okay, so that is 15. So what is the highest possible number? So highest possible number again is this 8. Okay, so let me write 1 with it. Okay, similarly, what is the second number when added with 8 will give me the closest possible number with 15? So that is again 4. So 8 plus 4 is 12. Okay, what are the other number? This 2 is when added, and this 1 will be added, because 8 plus 4 is 12, so plus 3 will give me this 15. So 2 plus 1 will also give me 3. So therefore selecting both of them, I will get what? I will get 15 here. So it will be the binary equivalent of it will be 1 1 1 1. So that is the binary equivalent. So similarly, using the same procedure which I have previously used, like that 8 multiplied by 1 plus 4 multiplied by 1 plus 2 multiplied by 1 and plus 1 multiplied by 1, what I will get? I will ultimately get this 15. Okay, similarly, the other question, let me first clear it. The other question now, part C of my question is 25. 25 in decimal. What is the possible equivalent binary number? So what is the nearest highest number here? So 32 is higher than 25. So let me select this 16. Okay, so how much is left now? So 25 minus 16 is 9. Okay, so now then selecting this 8 out of 9, so now 16 plus 8 is 24, and now 1 is left, so selecting this one here while others are 0 0. So that is what, that is my 25, because 16 multiplied by 116 plus 8 is 24 and multiplied by 1 will be 25. So the binary equivalent of 25 is 11001, this 2. Okay, so that is the binary number. So I think you have got the concept that how can we convert any decimal number into the binary one by using the sum of weights method. Similarly, if I have another number here, let me use here this d, and that is 50 in decimal. Okay, so what is the highest possible number here? That is now 16. Okay, how much is left now? 18 is left, because 50 minus 32 is 18, so that 16 again. So out of 18 I have got the 16. 16 plus 32 is 48, so 2 is left, so selecting this one and making others 0. So that is the binary equivalent of 50, and it will be equal to 110010, and that is in binary. Okay, now part E is 65 in decimal. So the highest possible number here is this 64, and 64 plus 1 is 65, while others are now zeros. Okay, so this is 1 and 1 2 3 4 5 zeros, so therefore it will be 1 1 2 3 4 5 and this one. So that is what, that is the binary equivalent of 65. So 1 2 3 4 5, yes, that is the correct one. Okay, so part E. Similarly, part F. What is part F? So part F contains 97 in binary, in decimal, sorry. So therefore now the highest possible number here is again 64. So 97 minus 64 is how much? That is 33. Okay, so now using this 32, so it would be 64 plus 32 will be 96, and this one 97, so all others will be 0 now. Okay, so now again it will be 11 4 zeros and 1 in binary. Okay, similarly part G. In part G of my question, what is this? That is 127 in decimal. So let me first remove it. So for 127 in decimal, what is the highest possible number? That is again 64. So 64 I have got. So 64 plus 32 is how much? That is 96. So 127 minus 96 is 31. So again now for 31, let me use this one here as well. So that would be 16 plus 64 is how much? That is 80. 80 plus 32 is 112. 8 is 120. 120 plus 4 is 124. This 126 and then 127. Okay, so that is now 127 and all the 7 bits which are 1. So let me use it here. So 1 2 3 4 5 6 7, all ones are basically the binary number here. Okay, so that is the binary equivalent of what? That is 127. Similarly, the last one here, and that is now 198. Okay, that is 198 in decimal. So I have to find the binary equivalent of this number. So what is the highest possible number? The highest possible number here is this 128. Okay, so with 128, when I will add 64, what it will be? So 64 plus 128 is 130, 130, and 62 is 192. So it will be 192. How much is remaining? 6 is remaining. Okay, so 192 plus 4 is 196, and 196 and this 2 is 198. Okay, so that is now 0 0, sorry, 0 0 0. So that is now the binary equivalent of it are 1 1 triple 0, okay, double 1 and 0. So that is what? That is the binary equivalent of 198. So that's it for today, in which we have discussed a table here, and you have to draw it because these are all the powers of 2's, and because I have to use the sum of weights methods, so it is mandatory to first draw this table, and then you can very easily convert any decimal number into the binary one. Okay, so that's it for today. I will see you with more interesting questions in our upcoming videos. So if you did not subscribe my channel yet, please subscribe it and like this video. Thank you so much, and I will see you soon. Welcome back, guys. So this is question number 12 of our book, in which we are asked to convert each decimal fraction to binary using the sum of weights method. Okay, so if you recall, previously we have converted our decimal numbers to the binary numbers by using the sum of weights method. But here this question is different from that of the previous one because it contains the decimal number which is mentioned here. Okay, so in order to solve these type of questions here, what we have to do, so if you recall again, so previously what we have done, we had the power of 2's which were the multiplicative factors with our binary numbers, and what we had to do, we had started it from 0, then 1, then 2, okay, and up to some power of 8. Okay, so these were basically the power of 2's which were the multiplicative factors, and if we had any number in decimal, we have to select any of these power of 2's by multiplying them with 1 or zeros. Okay, so the overall procedure were mentioned in that question, and the link of that video is now I'm attaching with this video. Okay, similarly, what happens if we have the decimal point here? So in that case, I will have the binary point in my binary numbers here. So in order to do it, what we will do, we will again use the power of 2's, but now the power of 2's will start from -1, then -2, -3 up to the higher term until and unless I want to find out the corrected version of my fractional binary number. Okay, so this was basically the introduction, and we can very easily see that if this is basically the 0 point, so here this is now, if these are the numbers, so here the powers will start from 1, 2, 3, 4 up to infinity, while here the powers will be from -1, -2, -3 up to the infinity. Okay, so here in order to do it, what we have to do, we are going to solve our questions as we have solved our previous questions. So here what we have to do, we have to start it from the binary point, then 2 raised to power -1, 2 raised to power -2, 2 raised to power -3, okay, 2 raised to power -4, 2 raised to power -5, 2 raised to power -6. Okay, so these are basically the powers of 2. So let me calculate them. So 2 raised to power -1 is 0.5. Okay, so let me call it 0.5. This is 0.25. okay, this is 0.125. this is 0.0625. okay, this is now 0.0312, and this one is, okay, this one is how much? This is 0.0156. Okay, so what we have to do, again the same procedure will be followed here, Suppose if we have a number which is now, let me have here part A, and in part A what we have to find out, we have here the 0.26 in decimal number, okay, and we have to find the equivalent binary number. So what it would be? So first of all, let me select the highest possible number which I can select from here. So let me start from here. So it cannot be 0.5 because 0.26 is lower than 0.5. So let me make it 0, okay. So multiplicative factor of 0.5 will be 0. Similarly, with 0.25, yes, it can be included because 0.26 is greater than this. So let me include it. So how much is now left? If I subtract 0.25 from this 0.26, how much is left? That would be 0.01. So therefore, this is now 0 because 0.15 is how much? That is now greater than what? If I 0.26 subtracted from it this 0.25, okay, so I will have 0.01. Okay, so I have to select this so that if it will be added with 0.25, I will get 0.26. So therefore this number is greater than 0.01, so it is not included. Similarly, this is not included, and similarities as well. So this one is the only possibility which I can include here, so this can be included here. Okay, so now I will get these numbers. So this is basically the binary number here. So let me use it. So it will be 0.010001. Okay, so that is the binary number. Okay, so how it would be calculated? Again, using the same procedure which we had previously used. So these two will be multiplied together. Okay, these two will be multiplied together. So here I will get 0, here 0.25, here 0 as well, 0, 0, and here 0.0156. So these will be added at the end, and you will see that their summation will be almost equal to 0.2656. Okay, because this is almost, if I want to get the correct answer up to the required number of decimal points, I have to move it to the higher number of binary numbers. So now I am stopping it here. So there it is now almost equivalent to the 0.26. Okay, so that's why I have calculated this number, and this is the procedure I can use to find the binary number from the decimal fraction number. Okay, so this is part A of my question. Okay, similarly, in order to solve the part B of my question, this is 0.762. so let me 0.762. so this is now here 0.762 in decimal, and the binary equivalent of it will be, let me remove it from here. So now let me see that if I had, what was that number? So 0.762. so 0.5 can be included here. This is lower than 0.762, so it can also be included here. Okay, so I will get 0.5 here. Okay, so what is the next procedure here? I have to subtract this 0.5 from 0.762. so 0.5 is here, so I will get 0.262. Okay, so now I have to see that whether the next number is greater than this one or lower than this. So it is lower than this one, so let me include it as well. Okay, so when it is included, let me subtract it from this number. So 0.25, so it will be 0.012. Okay, so now this is 0.012, and I have to select the next number, which is now which should be smaller than or equal to this one. Okay, so this is not the smaller or equal to this one, so that's why I'll make it 0. This is also the same case, this is the same case, while this one is almost equal to this one, so therefore I'm going to select it. Okay, so that's why this is now the binary number, and when the same procedure will be applied here, like multiplying the lower terms with the higher terms here and then adding them together, okay, what I will get? I will almost get the number which is mentioned here. So now, okay, so now let me remove it, okay, and the number which I have got here is basically 110001, okay. So that is my binary number, okay. So that is, as this is 110001, so I'll also have to write this binary point with it as well, okay. So if you want to make it more concise, so include this 0 with it as well, okay. So that is the binary equivalent of 0.762. This is part B. Similarly, now in order to solve this, what I have to do, let me solve it here as well. So here you will see that this is 0.0975. So let me use blue color for it. So what I have to select, let me solve it on the fly. So this will be included, and with it we can very easily see that this one will also be included, because adding them together I will almost get the 0.09, okay, and I am getting this point from these two digits. So therefore it will be how much? These two will be 0 0, this will be 1 1, okay. So I will get how much? This number will be 0.0975. This is part C, 0.0975 in decimal. It will be equal to 0.00011 in binary number, okay. So that's it for today, in which we have seen that how to calculate or convert each decimal fraction to binary using the sum of weights method. Although this is one of the lengthiest and very complex method, but it is mostly used by the practitioners who are fluent or has practiced binary to decimal or decimal to binary conversions frequently, okay. So that's why we have also discussed this method as well, and from the next lecture we are going to talk about the division method for converting our decimal number to the binary ones, okay. So that's it for today. If you have any questions, you can ask me in the comment section. Thank you so much, and I will see you soon. So another very important video in which we are going to convert each of the decimal numbers here to binary number by using the repeated division by 2, okay. So what is basically this method? Let us start solving our questions, and in solving it you will get to know that what is meant by repeated division by 2, okay. So the first part of my question is here 13, okay, that is basically in decimal, and I want to see that what is the binary equivalent of this number. So what we have to do, we have to write this number here, and I have to divide it over what? I have to divide it over 2 repeatedly, okay. So let me first divide it. So dividing it over 2, what I will get? So 2 multiplied by 6 is 12. So when 12 is here, 1 will be the remainder, and that remainder will be here, okay. So that is the remainder of the first division, okay. What is next? As this is the repeated division, again I have to divide it over 2. So when it is divided over 2, I will get 3, okay. So when I will get 3, the remainder of it will be 0, okay. Similarly, I have to divide it over 2 again, and I have to divide it over the number which is 2 until and unless I get 1 here, okay. So now again dividing 3 over 2, what I will get? I will get 1, and the remainder of it will also be 1, okay. So what is basically the procedure here, how I will write them here? So you can see that these are the numbers, okay. So I have to write my binary numbers, which will be started from here up to this one, while this one will be the MSB, okay, and this one will be the LSB, okay. So now writing it over here, what I will write, I will get here 1 1 0 1, okay. So that is basically my binary number, okay. So that is the binary equivalent of 13, and I can also check it here as well, that if I have 1011, okay, so this is now 2021, 22 and 23, multiplying them together, okay, and then adding them, what I will get, it will be 8 plus 4, okay, plus 0 plus 1. So what it will be, this is now decimal 30. So it proves that our method is correct and the binary equivalent of 13 is 1101. Okay, so that is for the part A of my question. I'm not going to solve each and every question here today, but I'm going to tell you the procedure, that what is the fundamental procedure of repeated division by 2 to convert my decimal numbers into the binary one. Okay, so this was basically the first part. Now let me solve part C of my question. Part C is 23 in decimal, and what will be the binary equivalent of it. Let me use the same procedure here. Okay, here this is 23, this is 2, I have to divide it over 8, so here I will get 11 with the 1 remainder. Okay, similarly here dividing it over 2, I will get here 5 with the 1 remainder. Okay, similarly again dividing it over 2, I will get 2 with the 1 remainder. Okay, and at the end I will get 1 with the 0 remainder. Okay, so that is basically 10111 is the binary equivalent, and I have to start it from here up to here. Okay, while this one is the MSB, while this one will be the LSB. Okay, let me write it here again. This is for your understanding. So now let me write it here. What I will get, this one will be 1 0 and 111 in binary equivalent. So these numbers are, this will be here, while this one is here. Okay, this one is here, this is here, while the last one is here. So these are basically the numbers which I have represented here. So this is basically the decimal to binary conversion. Now let me solve E here. Okay, so let me solve part E of my question. So what is part E? So part E is 35. Okay, so part E is 35 in decimal. Okay, so converting it into the binary here, what I will have to do, using the same procedure here. So 35 dividing it over 2, what I will get here, I will get 17 with the 1 remainder. Okay, similarly 2 here, what I will get here, 8 with the 1 remainder. Okay, again 2 4 with the 0 remainder. Okay, 2 2 with the 0 remainder, and at the end what I will get, 2 1 with the 0 remainder. Okay, so now again I have got these numbers, so it is again from here to here, and the binary numbers I will get here will be 1 000 11. This is the binary equivalent of this number, where this one is here. Okay, this is now here, and so on. Okay, because this one is now here, and all the numbers will remain here. Okay, so that's it for today, in which we have converted some parts of my question. And if you have any difficulty in solving any of the question here, please let me know in the comment section, and I hope all the conceptual of the questions is now clear. If you have any difficulty, I will try to make another video regarding the questions here. So till then, take care of yourself, and I will see you soon. So in last lecture we have converted the whole decimal numbers into the binary numbers. So now we have here decimal fractions, and we have to convert them into the binary by using the repeated multiplication by 2. Okay, so what is the method of repeated multiplication by 2? Let me solve part A of my question, and that is 0.76. Okay, that is in decimal, and I have to see that what is the binary equivalent of it. So the first number here I have is the 0.76, and previously in converting our number to the binary one, I had to divide it over 2 repeatedly. Now I will multiply it with 2 unless and until I will get 1 out of it. So multiplying it with 2, what I will get, okay. So multiplying it with 2.76 multiplied by 2, what I will get, 0.76 multiplied by 2, I will get here 1.52, okay. So here I will get 1.52, okay. So what I will do here, from this 1.52, what I will get, I will take this 1 here and put it here, okay. This will be the remainders box. So taking it here, what I will get here, now when I will get 1 from it, what I will have now I will have 0.5, okay. So I think it is clear now. What again I have to do, I have to multiply it with 2 again. So when I will multiply it with 2, what I will get here, I will get 1.04, okay. So now here you can see that again we have got 1 from here, okay. So taking it and putting it here again, this will be 1 1, and here when this is removed, what I will get, I will get here 0.04, and multiplying it with 2 again, what I will get here 0.08, okay. So when I will get this, here I have no numbers at the left side of this decimal point. So therefore what I have to do, this is 0, okay. So therefore I will write 0 here, okay. So here again I have this number and this is now again here. So writing here 0.08, okay, and multiplying it with 2, what I will get, I will get here 0.16, okay. So again what is here the number, here again this is 0, okay. So taking it, writing it over here, and I will again get here what, this is now 0.06, and again taking it, writing it over here 0.16 and multiplying it with what, multiplying it with 2, what I will get 0.32, okay. Again the same procedure, because now again I have 0 here. So taking this 0, this is 0, okay, and writing it over here, this is now again 0, okay. Again here this is 0.32, okay, 0.32 multiplying it with 2, what I will get here, this is, let me denote it with this black color here as well, with black color. So here I will get 0.64, here I have the 0, okay. So what I will get here, as this is 0, here again I will get 0. So this process will be repeated unless and until here from the multiplication of a number with 2 I get a whole number, okay. So this will take a lot of steps, therefore I'm not going to more steps here. So therefore the number or the binary equivalent of 0.676 is 0. Here this one 1100 up to the 4 binary points. This is the number and this is the binary equivalent of my number, where the whole overall procedure is listed here, okay. So that is for the part A. Similarly for part B of my question, here I have 0.56 in decimal, okay. So in order to do it, what I have to do, again I have to use the same procedure which I have had here. So 0.456, let me do it here as well. So 0.456 multiplied by 2, what I will get here, so here 0.456 multiplied by 2, here this is 0.912. So here 0.912, okay, and the remainders which are here, Okay, so the remainders are here. This is the remainder. So the remainder here, the first remainder is here 0. Okay, similarly taking it and writing it here. So 0.912 multiplied by 2, here I will get what? Here it will be 0.912 multiplied by 2, here I will get 1.824, 1.824. Okay, so 1 will be taken from it and here it will be put down. Okay, so let me use the red color here. So here it will be, so that would be 1. So 1 will be removed from here. What will happen? It will be 0.824 multiplied by 2. Okay, so again multiplying it with 0.824 multiplied by 2, what I will get here? 1.648, 1.648. Okay, from 8 1 here again I am doing it directly, and when 1 will be removed it will be 0.648 multiplied by 2. Okay, so here again, so that would be minus 1, it would be 0.648 multiplied by 2. So here it will be 1.296, 1.296. Okay, so again from here 1. Okay, and here 0.296 multiplied by 2, what I will get? Subtracting 1 from it, that is now this, and multiplying it with 2, what I will get? 0.592. Okay, so 0.592, here, writing 0 here as well. Okay, and doing it again, 0.592 multiplied by 2. Okay, so what I will get here multiplied by 2, so it will be 1.184, taking it here and writing here, and it will be repeated and unless and until here I get 1.00. Okay, so that's why now here I am writing it here. So up to the 4 binary points here I will have 0.1110. Okay, and that is the binary equivalent of my number, which is 0.456. Okay, so that's it for today, in which I have solved first 2 parts in order to give you an idea that how decimal fractions can be converted to the binary numbers. So it's the end. That's it for today, and I will see you with some more questions in our upcoming video. Thank you so much, and I will see you soon.